Hello there. Let's do this rather standard problem. Um, so we have a electric charge Q that's at this point moving in that direction. Has a speed u, and the angle with the horizontal is the theta at that point. So this is like a t equal to 0 situation. And there is an electric field here in this region, this region between the plates. There's an electric field, and because of that there is a force, or electric force is in that direction, because this is a positive charge, so it will be in the same direction as electric field. There is electric field because this plate and this plate have a potential difference between them, and electric field in this region, will be equal in magnitude, will be equal to the potential difference divided by the distance of the plate, right? So delta V over the distance of the plate, because it's uniform. So electric field here is uniform electric field. Now, why all of this case? You have to study earlier chapters, earlier videos. We talked about if you have a plate, two plates, and this is a potential V, V plus, and this is V minus. Then at this any point here, the electric field will point it this way and have magnitude V plus minus V minus over the distance of separation between the plates. Okay, it is a parallel plate capacitor in a way, right? But we're not using this as a capacitor, we're using the electric field. So that's the force, and we're supposed to find out how far it will travel before it strikes the lower potential plate, negative plate. Okay, it's a very standard problem, and you should try to do it. Now, some of you may be wondering, when I was a student, I did wonder what happened to the gravity. Well, we will assume that this is much more than this, otherwise we have to include mg in it, right? So mg is also mg, there are two forces, so mg is also in that direction, and this is equal to charge times electric field. So if this is very, very small compared to this, we may ignore this. And often we ignore this because the electric force is much, much greater. For a elementary particle, you can say the charge is even very small, and mass even smaller. Okay, and because of that, the value of G versus the E is very different. For instance, say this was a let's look at magnitudes. So if this D is 1 centimeter and this V is say 100 volt, then what's the E? E will be 100 volt, and this is 0 volt minus 0 over the distance 1 centimeter is 10 to the minus 2 meter. You already said 10 to the 4 volt over meter. And so E, say you take a proton, so E will be 1.6 times 10 to the minus 19 coulomb. Let me check, it's 19. So then the E times E will be 1.6 times 10 to the power, and 19 and 14 makes it 4 makes it 15 Newton, right? Now the mass of a proton, mass proton is like 1.67 times 10 minus 27 kilogram, and G is 10 meter per second square. then you can say that m mass of proton G is just 1.67 times 10 to the power minus 26 Newton. So you can see the difference is so big, then we can just ignore this part when you're dealing with this. But it's a problem which is close to what you have done when you did the problems like this in like a first part of the course, right? Okay, so what do we have? I hope you can just pause it and do this problem yourself and then come back and check my answer. Okay. All right. I'm going to do it. There is this distance is missing. Let's this distance be this distance we want. This distance is d. Then the height, let's call it h. So it's going to be like that. And it's going to come down over here, and so we can draw. So let's call this y-axis, let's call this x-axis. So this is the x final I want. X initial is 0, y initial is over here is h, and this y final is 0. So because of u and theta, you have v initial x is u cosine theta, and v initial y is u sine theta, and the acceleration is this way. So acceleration x is 0, acceleration y is in opposite direction minus e over m. That will be the acceleration by using F equals ma, ignoring gravity, right? So now we have all this. Let me clean this up and I will try to do the problem over in this area. Okay, you already know we can generate the equation t from t equal to 0 here, and this is t equals to t final. T initial is 0, t final is t, and so we have along the x direction we have the velocity doesn't change. So if this is the distance d we want, so d equals to vix times t, because delta t is t, and so this is like a v equals to u cosine theta this times t. So this one equation. And in the y direction we have it went down h in the same amount of time. So in the same amount of time it went down h. So y final minus y initial, so 0 minus h is v I y t plus half a y t square. So this gives me minus h. Minus h is and then this is u sine theta times t, and this is not g, ay is this number, and it's actually negative, not positive, because this pointed in the opposite to the axis. T minus half e over m t square. So we have pretty much everything that we need to solve. So solve for d, right? So this one, let's call this equation number 2. We can solve this for t, and then plug that in here and get a d. So this is a quadratic equation. 1t is when it was at this point in the y, same y equal to 0. So this is like in the past, and 1t is in the future. So the t, I need a t in the future from here, right? So I'm just going to do bring everything this side. So this is half e over m t squared. So this is one coefficient, and bring this guy over here, minus u sine theta t, and then minus h equal to 0. So the t is just going to be 1 over 2 this number, so that's going to be 2m over EE, 1 over 2a times minus b, this is going to be u sine theta. Then you have a plus and minus, but we don't want a minus because we want future square root, so we ignore minus. And then this is going to be square u square sine square theta, then minus plus, and then this is going to be plus, and 4 times that comes 2 e h over e is actually q, e is q for us, q over m. I think I didn't. So that's the time, and you just plug in there. So the d is just simply this number times t. So you have a m times u times cosine theta over QE. Let's call it QE. U cosine theta plus square root of u square u sine theta, not cosine theta, sine theta, sine square theta plus 2QEH over m. So that's the answer. It looks a little messy, and sometimes you can just plug some numbers and get the answer in a very nice numerical value. Okay, next set of topics we're going to do is start with now moving charges, and then they lead to what is called current, electric current, and we'll learn about electric current, how electric current actually causes another field called magnetic field. So in addition to the electric field, and when the charges are moving, you can also have magnetic field. That's the next set of topics we're going to go to. Okay, see you, bye.